Okay. All right. So today we will learn linear algebra, and linear algebra is nothing but it's a branch of mathematics which concerns learning about linear equation. And linear equations are of the form a1 x1. So you don't have to actually remember all of this, but just for the sake of understanding what we'll be dealing with. So this is what it is. So we'll be mainly dealing with equations that are linear in nature. Now what do you mean by a linear equation, right? A linear equation, for you to understand a linear equation you have to understand each and every single term that is there in that equation. A linear equation could be something like, let's just say, um, you want to walk from your home. Okay, from your home. Okay, give me a minute. Okay, so never mind. So let's just say there is a point A. Okay, from your point A is H, and point, let's just say gym, you want to walk to gym. Okay, so you started here and you will stop here. So this, during your walk, one, you took the direction of walking, and two, you covered certain distance. Okay, so you walked in particular, of course your it is never a straight line, it is always going to be left right, go straight that way it is going to be. But nevertheless this is also a distance covered metric, right? So this is called as a Manhattan distance, but we'll learn those later on as advanced topics. But the point I'm trying to make is, in linear algebra you are dealing with linear equation. Now in linear equation you're dealing with individual terms a1 x1, uh, up to an x1. You have to understand what that each term is to understand what linear equation is. So in linear equation, basically, if you walk from your home, let's just say you walk for 1 kilometer. Okay, um, what it means is, okay, you have covered 1 kilometer by taking one step at a time. Okay, so if I am to convert this into a linear equation, in order to reach the total value y, okay, you had to take x step, x distance, okay, in the form of x steps. Okay, so this becomes your linear equation. So a into x equals to y. So one step at a time you took, for 1 kilometer you took, and finally your value became 1 kilometer. This is direct dependency. If you notice, for every step you take, okay, you are inching towards your destination gym. Okay, if you had to, if let's just say gym was 5 kilometers, you will still take the one step only at a time. So your steps, your distance are directly related. How many steps you take, so much distance you will cover. You see, how much distance you take, so much distance you will cover, and so much length you would have covered in the end. So they are directly proportional. Now here a is constant because your step length is same. Maybe you will take a step length of 50 centimeter or 0.5 meter. Okay, that is a average, human average anyway. So if you take that step length, this becomes a constant. Let's and constant is fine. But the after the distance, small distance that you covered after walking that 0.5, taking that step length, so you would have covered with two step lengths, with two of your legs, you would have covered 1 meter at a time. Now this 1 meter, what I'm trying to say, is directly proportional to the total length that you will cover in the end. Because one step, the two steps that you take, you will with those two steps you will keep on inching closer to your destination. So the point I'm trying to make is these are directly proportional. Okay, and they are, you don't see a squared term. Okay, you don't see a squared term here, which means uh, it is completely straightforward. In order to cover the distance, one second, someone is waiting. um, okay, so in order to cover the distance 1 kilometer, you are taking the step length, hence they are directly proportional. You have uh, pretty much straightforward elements here, both a and x, hence they are called as linear equations. Linear means if you plot them, okay, if you plot them on x and y, you will see a straight line, something like this, because they are directly dependent. And if you add another term here, that during your walk you got tired and how much of water did you consume. Okay, for a person to walk 1 kilometer, let's just say he consumes 300 ml of water. Okay, and for a person to walk 2 kilometers, let's just say he consumes 600 ml. So that way, if you calculate for a person to consume water for 10 kilometers walk, it would be 3 liters. He would end up drinking 3 liters of water for 10 kilometers walk. So this is just an example, hypothetically speaking. So if your terms are directly related, directly proportional, then they form linear equation. Directly proportional as in there you don't see any extra terms, multiplication terms, as in the square or the exponential factor, that way. So those will be called as polynomial or exponential equations. They are not called as linear equation. So basically linear equation is the equation, okay, or a linear equation system of linear equations are the equations that represent upon plotting that give you a straight line. Okay, so you can go through, I will give you all these links, you can expand your understanding. um, you can brush up your mathematics that you have already learned in your school. But again, these understanding the concepts is more important than knowing the definitions. Okay, so just pay attention please. So these links I have added, you can go through. Now the first concept in linear equation is, see this very point that we discussed, step length, that becomes your scalar. Basically any value in linear algebra that has only a value, that doesn't have a direction. Okay, basically step length could be step length in any direction, right? There is no specific direction to it. Step length is a constant, so hence it becomes a scalar. And x becomes your a vector value. Why? Because you are taking certain direction to reach your destination. Okay, so that will be called as a vector. Now in this case it's a vector. Why? Because it has magnitude 1 kilometer, it has also a direction, certain direction only you can reach gym. If you take opposite direction you can't reach gym, or you go this direction you can't take gym, right? You have to go in that direction only in order to take gym. Okay, so that will be called as vector. And there is this beautiful high school mathematics. Okay, um, so wherein which they have explained everything. So a vector is nothing but a line. Basically a vector is a line. Okay, vector is a line, scalar is a point. Okay, that we will see how to plot them and how what it means. Okay, programmatically how to do it, so that we will see. That is our area of interest. But nevertheless you have to know all these things. Scalar is a dot, whereas vector is a line. Okay, this is a vector. And like that you have magnitude a dash here is represented as magnitude of vector a is to b, and and let A be your home, B be your gym. And so the standard form also is represented. Basically a vector A could be addition of multiple factors. Okay, so here mathematically for this vector they have represented in the form of ijk, which means three-dimensional vector. Okay, it's a three-dimensional vector, and that we will see. Again they are saying it's a ijk are unit vectors themselves. Okay, they are represented in three different axes, and it's a three-dimensional vector. So this we will see. Okay, one by one we will see. Let's just say but in programming, why do you need vectors, why do you need algebra as a data scientist, is because it turns out in this entire universe, the universe that we live in, everything is three dimensional. Okay, everything, basically everything is three dimensional. If you observe a bird flying from one direction, from one point to another point, it turns out that only capturing its magnitude is not sufficient. You need to know which direction it is flying, so that you can calculate where it would land. Okay, um, so again I'm saying for bird you can calculate it for aeroplane. Okay, so that way anything that moves or anything in 3D space, we will also need to know its direction. That's where vectors come in. Okay, and combination of multiple vectors can be represented in the form of an equation, and that becomes your linear equation. Hence linear algebra we are studying as data scientists. That is one. Second reason is because every object is represented as a 3D vector. Okay, it turns out if you want to process an image, converting that image into I mean again converting that image can be easily done into a form of matrix, which is a combination of vectors. Again, matrix is a combination of multiple vectors. Okay, now once you convert that, you can calculate. Basically you can take an image or a text or tabular data or anything. Basically any data can be represented in the form of vectors and matrices, and and we can calculate the operations. That way we can understand the data better. That is why we are learning algebra, linear algebra. Linear algebra is important for us simply because magic, you can think of it like either magically or mathematically or just the way how things are in the universe. It turns out that any data that has been captured can be converted into vectors and matrices. Okay, okay, let's start with our vector understanding. I'm gonna use something called numpy. Okay, so numpy is used for numerical calculations on vectors on linear algebra. And I'm also going to use something called matplotlib. Mat is mathematics, plotting library. Okay, something like that, you remember. And in that there is something called python plotting, pyplot. So that I'm going to import as plt, or I'll okay, I will for the time being I will. Okay, never mind, I will import like that only, so that you also can get used to the same terminology. Okay, I will import this. And in order to show you, someone if car is honking, please mute, please, whoever that is. Okay, so again we will also import something called matplotlib toolkits. Additional toolkits are provided for this matplotlib library that allow us to plot 3D axis. Okay, so for that I will import this. You don't have to remember all this. Okay, so just remember, you can import matplotlib, you can import numpy. Okay, don't break your head with this. You will always get this on internet. If you don't, if you forget, I will import all these three libraries so that I can start working on my vectors. Okay, now let v1 be a vector. Okay, and all the vectors are represented within square brackets. This is first thing. So let's just be a vector be 3 comma minus 2. Okay, this is my vector. And in order, because it's a vector, as you can see, one moment please. Okay, so because it's a vector, you can print, okay, v1 of, you already know the indexing, right? So you can access its first element, you can access its first other point also, or you can do a print of second point. Okay, so vector is nothing but, in mathematics, in linear, in our data analysis, is just a square bracket with starting point and ending point. Basically, if you want to realize this, okay, if this is your xy axis, it starts at 3, okay, and ends at -2. This is -1, -2, 1, 2, 3. So this line is what we are talking about, and always this value is x, this value is y, always. Okay, that way. So this vector is going from 3 to -2, hence the direction is this. Okay, this is your vector. The point that we have represented here is that point. We are trying to access first point and second point. Okay, and if you want to represent the two-dimensional vector, you will just simply add another one or something. Okay, this will be your three-dimensional vector. Likewise, you can access the single points. If I type v2, you will get 3 2 comma 1, and this would be your, let's just say you also have another axis. Okay, three-dimensional axis. Then what will happen is, this will be your 1, this will be your 2. Okay, let me erase this first. Okay, like this. So this will be your 3. Okay, and this will be your again -1, -2. Okay, now this vector will is starting from 3 and then 2 and 1. This, okay, I can't exactly show you. This would be something like this, but you'll have to move this three-dimensional axis to understand what it looks like. That we will see. Okay, we will try to represent a 2D vector and 3D vector. Now this v1 and v2 I have. Now how do I plot it? To understand, so we have something, we have already imported that plotting library. To plot, we will use something called plt.plot. Okay, and now you have, okay, a vector, that is, you have to plot by passing a vector. Okay, now you know the first point, it's starting at 3. Okay, for the time being I will directly type those values. Let's just say 3 comma -2. Okay, uh, so it's starting at, okay, I will explain you why this is like this. Okay, 0 comma 3, because the point I'm trying to plot, okay, let's just say like this, 2D vector, it's a two-dimensional vector going from 0 comma 0 to 3 comma -2. Let's just say, so for the time being, so it will be x-axis will be 0 comma 3, and y vector would be 0 comma -2. Okay, okay, it would look something like this. But you just looking at this line, you won't understand what it means. Okay, this is your vector, you won't understand what it is. That's why it's better to add axis also. Okay, let's try to add that axis. Now if I notice the points are going from 0 to 3, so I will try to add axis from 0 to 4, and it's going from 0 to -2. Let me add from 4 comma 4 comma -4 comma -4. Okay, so axis for axis something, okay, 2D axis. Okay, so just for the time being, plt dot plot. So you're just trying to plot these axes as well. Later on we will see how to do this in a better way. For the time being, I'm trying to type, let's just say this will be my dotted lines. Okay, so this I want them to be dotted lines. We will learn numpy in detail, matplotlib in detail. Don't worry about what I'm typing, but just see how to plot. You try to understand, this is your vector, these are your coordinates. Okay, coordinate system I'm trying to plot. Okay, the way how I'm plotting also I will explain. Okay, now it has to start from again 0 comma 0, again it has to go from -4 comma 4. Okay, that is also this thing. Again plt dot grid. If I plot this, you see what happened. So what basically what I'm trying to do is, initially when I had this alone, okay, I had this line, I was not understanding this line is still the same line only, but what happened was I didn't understand. Basically anybody would looking at this line, they would simply see a line, they won't understand the coordinates, where it is starting, where it is ending and all. That is why what we have done is, we have seen this x-axis 0 to 3 it's going. So what if I draw something that goes from 0 to 4 instead? That way I'll be able to visualize 0 to 3 easily. So 0 to 4 I have added. Okay, 0 to 4, in order to add 0 to 4 you have to take the x-axis. So this is 0 to -4 here in this direction. 0 to -4 I have added, and okay, if talking about the points, -4 to 4. Okay, this line -4 to 4 coinciding with 0 comma 0, again 0 from 0.0 to 4 comma -4. This is 4 above, and this is your -4. Okay, so that way we have plotted it, and we have added a grid will add these boxes behind. If you don't add this grid, okay, you'll get this plain thing. So that's why I have added grid 2 for better understanding. So we will see at what point they are ending and starting, right? Now you can also add axis values. Okay, so let's just say you want to add a title. Okay, so you can simply type 2D vector plt dot title. If you add, it will add a title from 0 comma 0 to 3 comma -2. So adding this will add a title here above. Okay, plt dot title. And if you want to add additional axis, plt dot axis. Okay, in the axis you have to specify what it's going to be, -4 comma 4, and then you have -4 comma 4. Now see, it added the exact axis. Okay, now what happens if you highlight this? You see, so these were added as dotted lines to to get the axis. This is added to get the entire box itself. Okay, and this is added to get this inside mesh that you are seeing. Okay, and this is your vector, and this is added to get the title. So I'm gonna unhighlight that. This is for dotted lines so that we can understand better. This is our kind of a coordinate system. This is how you can add coordinate system to visualize the 2D vector. This is a 2D vector. Now you know this is one single vector is going from 0 to 0, 0 comma 0 to point 3 comma minus 2. Is this clear? This is what a vector is. This line, blue line, is a vector. Did you understand what is a vector, and did you understand how to plot a vector?
Yes, sir. Yeah.
Any doubts up until this point?
Yes, yes. I do have some doubts here.
You
This,
need to be little bit louder, please.
hello?
Yeah, yeah.
Yeah,
Tell me.
yeah. The axis plot PLT dot axis, it is minus 4, 4, minus 4, 4.
Mm-hmm.
So that I'm not getting my
Okay.
PLT dot axis. Yeah,
Mhm.
yeah, because it is uh,
See, minus
so
4 is
it,
to 4 means you see the x-axis. Minus
yes.
4 is to 4. Okay. Again, minus 4 is to 4. Okay. Let me change the values. Maybe you will understand it. If I change this to minus 6, okay. See, it's going on the left side. Minus 6. Starting
Okay,
value is being manipulated. Minus 6.
okay, okay,
Okay.
okay.
Is to 6. Now watch. Now this
Hmm.
value is increased. 6.
Okay.
Again, if I add minus 5,
Yes, got it. Got it. Got it.
yeah, this value is. So basically you are
Okay.
manipulating the
Box
axis
size,
system.
box size. Okay. And one more, when we are actually plotting the vector itself, uh, can you just scroll down the, I mean,
Is his
the,
voice feeble only for me or for
okay.
everybody else as well? Um,
Follow. Yeah. Hello.
yeah, yeah,
When we
Sachin,
are
I can hear
actually
you.
plotting, when we are actually plotting the vector there, the blue line, can you just take that, scroll it down a bit? Scroll down.
Sure.
Yeah. So there PLT dot plot
Mm-hmm.
now 0 comma 3 is one point and 0 comma minus 2 is another point, right?
No, 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 no. This, the way how you are plotting this is correct, correct. You're right. 0 comma 3 is one point, and 0 comma
Yeah.
minus 2 is another point. Yes.
So the x coordinate for the first point is 0 and y coordinate is 3. Is it like that?
No,
X
this is
comma y.
x comma y. Okay, let me add it here. Okay. So this is something like, for the first point, this is x value. Okay, so x on x it is 0. This is y value for the point
Y.
1,
Yeah.
or you can imagine this as x1,
X1, Y1,
y1.
X1, Y1, and X2,
Okay,
Y2.
x2, y2, x2, y2, and this I will add a hash here.
Yeah. Now looking at the first line, which is commented,
Mm-hmm.
2D vector from 0, 0 to 3 comma minus 2.
Yes.
So 0, 0 has to be x1, y1,
Mm-hmm.
and 3 minus 2 is x2, y2.
Yeah,
But
you're right.
eventually
You're
it
you're
looks
right.
that
You're right. Yeah. So this has to be x1, y1 actually. Correct. And this has to be x2, y2.
so it seems that it is x1, x2, and y1, y2.
Yeah. Yeah, it is x1 and x2, y1, y2. Correct, correct. Yeah, for this vector it is correct. You're right. So it is x1, x2, y1, y2. Um, and you
So you
can
mean
plot it. Mhm.
when we plot the vector for 2 points, so we have to give it as the first, like the array of x comma array of y. Is it
Sorry,
array
when
of
you
x
plot,
values?
uh-huh.
yeah, I said when we are plotting the vector, like let us say the points are from origin to
Mm-hmm.
3 comma minus 2.
Okay,
From
okay.
origin,
This point, yeah.
what is stated there is the commented line says we are plotting a 2D vector from origin to a
3
point
comma minus 2.
in
Correct.
the fourth quadrant. Yeah, fourth quadrant. Correct.
Right.
Now, so when we need to plot it with the help of plt dot plot,
Mm-hmm.
so are we supposed to give it in the format of the array of x values of both the points,
And y
comma,
values,
array
yes.
of y values of, okay, that's the
Yes, yes.
format.
Yes, yes. Correct, correct. Sorry for the
Okay.
confusion. Yeah, it is like that. Yeah.
No, no.
First, you have to specify the x while plotting. See, while
Mm-hmm.
understanding,
Okay.
we know it is x1, y1.
Yeah. This.
Okay.
Okay. Okay.
While
Thanks.
plotting,
Thanks.
it is x2, x1, x2. So that is the confusion. Okay. Um, so while plotting, you take as x1, x2, y1, y2. Okay. Any other doubt? If we visualize this in uh, 3D space, we will understand better. I will have
Yeah.
to.
Now I understood. Yeah.
Okay.
Yeah. Now I understood.
Okay.
Because generally we conceive it as x1 comma y
Correct.
xy.
Correct.
Okay. Fine. But thanks.
Correct.
Yeah.
So generally, it is like that. Our understanding of mathematics is different from geometrical plotting, programmatically. But when we plot humanly on a paper, then we plot it in that sense only: x1, y1, x2, y2. But while programmatically handling, so we have to remember x1, x2, y1, y2. Here also the same thing. We had this 3D vector. Now, for us to visualize this 3D vector, we'll have to draw a 3D plot. Now, how to do that is, we have something called, I'm calling the figure method, okay, which is already provided. Okay, if you notice, this figure method is used to create a new figure or activate the existing one. So basically trying to add additional functionality to the existing one or create a new one. Okay, so how it works is all explained here. Okay, you don't have to know all of that, but just remember that you have to call that, and to that you have to add a additional axis, right? So by default it will anyway create the two axis, and now we are trying to add additional one. Okay, axis dot subplot, and I'm calling the projection. I want it to project it. I'm adding the extra axis, but I want it to project it using 3D system. So now to that axis I'm gonna plot a 3D vector. Now 3D vector again is the same story. So if I'm to plot a 3D point, okay, let me add that as well. 3D vector from going from, okay, um, 0 comma 0 comma 0 to 3 comma minus 2 comma 1. Okay, so in order to add that, like uh, what you pointed out, so it has to be x1, which is your 0 comma, again you have the next point is 3. Okay, that is in your x axis. Now in your y axis again 0 comma minus 2. Okay, this is your y axis, and again you also have z axis 0 comma 1. Okay, so if I do that, you get the vector in the 3D space, and now you can go on to add the additional coordinate system if you like. So first let's add that ax dot plot of 0 comma 0. So this is just the dotted lines that I'm trying to add, just to represent the 3D axis. Comma. Is the same thing, it's just that I'm adding one additional coordinate system, and so if I add this, Okay, let me add the complete lines. I This has to be the other points minus 4 comma 4. Okay, now you got the vertical line. Okay, and to add the horizontal line, I will modify this point only, minus 4 comma 4. Okay, you got this line now. Now I will add another line. Sorry, this also has to be 0 comma 0. That's why it's, so this has to be the, let's just say this point, and this has to be 0 comma 0. Basically I'm just trying to define the starting point, ending point for all the three numbers. Now you can see you have a three coordinate system. Your vector looks like this. It's starting from 0 comma 0 comma 0, okay, which is at this point, and it's going up in the three value along the alongside of x-axis. If this is your x-axis, this coordinate system is your x-axis, it's going at 3, and along the vertical axis, which is your this axis, is going at 2, somewhere here, minus 2. Okay, and at z axis, this is difficult to imagine. At z axis, which is your this system, is going at one value, maybe somewhere here. Okay, if you notice, I wish it was interactive. Maybe let's just do one thing. Let's plot some other vector where we can see much higher difference. Okay, instead of, let's just say 4 minus 3 comma 4, I will change the values.
And if you get in the first octant, it will help.
Okay, okay, let's make everything positive then. Okay, so let's just say 4 3 4, something like this. Okay, now from 0 comma 0 comma 0 it's going up until, okay, so if you can notice, it's going up onto 4 along the x-axis and 3 along the y-axis. The y-axis you can easily understand, it's at 3 only, and x-axis not very clear, still not very clear, but if this is your x-axis, it has to be at 4 somewhere here. Okay, anyway, so 4 comma 3 comma again 4, even along z-axis and x-axis. If this was interactive, we will see interactive maps, okay, interactive plotting in when we talk about plotly. But for now, just understand, try to use your imagination. So it is pointing at 4 comma 3 comma 4. Okay,
The
what if,
plotting
yeah,
of axis
yeah,
here. Again, we are giving the plotting of axis there, like 0 comma ax dot plot, where we are actually mentioning k hash hash or hyphen hyphen k hyphen hyphen. We are mentioning there. So there, again, are we giving it in the form x1, x2, y1, y2,
no, these are different.
and
See,
z1, z2?
no, those are not, those are different. Okay, see, these are your dotted lines. uh,
Yeah, that's right. So those are basically those are representing the axis, no?
Correct, these are representing the axis. Let me hash this out. um, okay, so in order to get that dash system, um, okay, these, see, these you have to, okay, let me explain here.
So there actually we are having it's a 2D system there.
Correct, it's a 2D system here. Here, for the dash, no, even if it's a 2D system, especially for the dotted lines, okay, you're just adding one additional point. See, for the existing minus 4 comma 4, minus 4 comma from -4 to +4 you wanted to add these line. Okay, and 0 to 0 you added this line, right? So that's why you have specified it as dash lines. But for these coordinates only you are adding one additional point, which is your additional coordinate 0 comma 0.
Yeah, that is the additional line which is in the dotted form.
Correct, correct. What is
Yeah.
the question?
No, actually, can you just state there what is X and what is Y
Mm-hmm.
in the dotted lines? Like we mentioned in the for plotting this
Okay.
blue color line, we are having it is like X1, X2, Y1, Y2, Z1, Z2.
Mm-hmm.
Oh, okay, okay. So that's what I'm not able to understand actually. Uh, First point is like X1,
See,
X2
first point
for
is
the
correct.
no no yeah for yeah X1 X2 Y1 Y2
Okay, this
and
is
Z1 Z2 there. Okay, okay, I'll check it out. Don't worry. I mean, ठीक है,
okay.
don't worry.
So
You
this
can please
is
proceed. I'll check it.
okay. So this is your 0 comma 0 comma 0, right? This is your origin. So clearly, when you write it or try to understand, this is your x1, y1, z1.
Sadiq, maybe we can clearly understand on whiteboard. If you can draw on whiteboard.
Sure, sure. Okay.
No, I think it's okay. It's okay. It's okay. No worries.
Uh, okay. So, in, is it required or not required?
No, 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 no. It's fine. I mean, let's proceed further.
Mm,
I will just make some changes there
Mhm.
in this thing. I'll get about that. No worries. Thanks.
Okay.
no,
I'll check that.
but if you can do, please,
Okay.
because I'm also
Sure.
confused
Sure.
in that. Yeah.
Sure. Sure. Okay. Hold on. Okay. So what we sorry for my straight lines. Okay. So what we are saying is this is your coordinate system, right? So the way how we understand is for a point we understand, let's just say if this is the origin 0 comma 0, we make we understand it as x1 comma y1, and another point 3 comma 2 as x2 comma y2. Correct? X2
Yes.
comma y2. This is these are our
Yes.
values. This is how we understand. But while plotting, it is important for us to specify in this manner x1, x2, which is x1, x2 means along the x axis it is 0 only, and it is somewhere here. The way how the graphing library works is it first tries to understand these points. It comes here, okay, 0 comma 3, and then y1 comma y2. So y1 is how much? Again 0 comma 2, somewhere here. Okay, this is your 2. But when you plot, when you specify x1 and x2, which is 0 comma 3, which is actually this point and this point, right? So we would naturally, I mean the graphing library, okay, how the way how it is coming, understanding this is, okay, this is your 0 comma 0, 3 is here, so it will come along the this line, okay, somewhere here, and it will try to understand this point 2 comma 2 somewhere here. Okay, and what it will do is it will look at the origin point, and to this point it will draw line. Okay, our understanding is little different from the graphing library's understanding. So our understanding is the way we look at is a point wise we look. Okay, but mathematically the way how it has been designed is it wants to understand what is along the x-axis. It will the graphing library will come here, the pointer, and it wants to understand what is along the y-axis. So basically always when you are giving the points here, first whatever the x coordinates are there, that you will give whatever the y coordinates that you will give, and whatever the z coordinates are there, that you will specify. Okay, so always x, all the x values are given here, and then y values are given here, and z values are given there. Okay, so is this clear? I mean the way how graphing library is seeing versus how we see, there is a difference.
Yeah, yeah. Yes,
Okay,
yes,
Yes.
yes, it is. Yes.
now
Yes.
let's just say there is another axis also. Okay, something like this. Okay,
Z axis.
z axis. Now the same point, 3 comma 2 comma, again let's just say 2. 2 is again 0, 1 comma 2, somewhere here. 2 is somewhere here. Or maybe let's just say 3, or even 4. We will go for 4. Okay, now our point is 3 comma 2 comma 4, which is your z2, and here it is your z1. Okay, now we know this is 0 comma 0 comma 0 point. Okay, from here, the how graphing library sees, it sees along x-axis, it sees this point. Okay, the point is here, it sees along this point. Okay, it tries to come to a common point for those two, and now it also has to see, the z-axis. So it comes to the point here. Okay, from the triangulation it has already seen the graph here. Now it tries to move this to in this direction, and now it plots somewhere like this, where sorry, I will draw the proper one second. Okay, so now if you take, it has to meet both 3, 4 and 2. So 4 is this perpendicular you have to draw. So this has to be perpendicular, this has to be perpendicular, this has to be perpendicular. Okay, so that way perpendicular you have to draw. Now the point, okay, let me take out this 3 comma 2. This will cause additional confusion. Okay, okay, so first, this is your 2 points, and this is your third point, right? So this is your 3, this is your 2, and this is your 4. Now the vector has to be drawn in such a way that it meets all the 3. So first, where is the point of intersection? Somewhere here, somewhere here. Okay, so now a plot is drawn such that it meets here. Okay, you assume 2 is here, equivalent to this. Sorry. Okay, you assume like this. Okay, now it's proper. In this direction it is meeting the 4 value. In this direction it is meeting 3 value. In this direction it is meeting 2 value. Okay, is this clear now?
Yes. Yes.
So the way graphing library sees versus how we see is little different. That is where the confusion is arising. The way how we see is x1, y1, z1, but the way how graphing library sees is all the x coordinates first, all the y coordinates first, all the z coordinates first. The same thing is applicable here also for the dotted line. For the, in order for you to draw the z axis, okay, if I remove these two, for in order for you to draw the z axis, okay, you have to define the height of the z axis. That is what you're defining here. You want the height to be go from -4 to 4. Again -4 also you're defining in, okay, in the negative direction. So -4 to 4 you're drawing. Okay, and when you add this line, see how it
Got
tries
it,
to
got it,
triangulate both.
got it.
It's calculating
Yeah,
line by
yeah.
line. Okay, now it tries to draw it. It already has one point, it understood. Okay, the length has to be, height has to be 0 to that is -4 to 4. Okay, it understood. Now on top of that, it tries to calculate the width. One, it calculated the height, this value. Now it's calculating this width. Okay, this width from this point to this point. And when you add additional third point, now it has to calculate the entire uh, this length also, and that's why it's triangulating. Basically, basis on the triangulation it's working. That is why it's little you know tedious to understand. Okay, but once it calculates, you will be able to visualize the vector like this, something like this.
Can you please change the last line instead of -4 to 4? Can you just make it 0, comma 4? I think that will make the things box plot kind of thing. Yeah, 0 there. Just
Okay,
yeah, I
is
think
this
this
also
is
fine?
giving a
Much
yeah,
better
this
one.
is giving a better understanding actually.
Okay.
Or for actually y-axis also, like for the width, if
Mm-hmm.
we mention from 0 to 4.
Y-axis also.
Yeah, there I think it will give a better visualization if you check that. Fine,
Is
fine,
this?
we understood. There's no need to change it as per my request. You can keep it
No,
as
no.
it is. But I got it. Thanks,
At
thanks.
the end of the day, you are the ones who are supposed to
No,
understand this
I
and
got.
apply. Yeah.
Yeah,
So
I got
okay.
it. I
So
got
this
it.
is how vector representation works. If we have understood this concept, then it will be really, really helpful. Okay. Uh, for me to explain you the next set of concepts. Is this clear for everybody?
Yeah, Sadiq,
Yeah.
one other thing other than this, can I just, because you have paused here, so uh, the SQLite recording last
Yes. Yes.
Sunday, I had to,
Yes. Yes.
I
I
did
saw
not,
your message. Okay. SQLite
no worries.
that I will upload. Okay. Don't worry.
Yes, yes. Okay,
Okay.
thanks.
All right. So okay. Up until this point, if you have understood, I want to just stop, take a pause, finish your breakfast, and come back. We will see the additional next set of topics. Any doubts, please ask now.